Hello again, space enthusiasts. It's great to be back with another video delving into the mysteries of the cosmos. Back in the 1970s, scientists were meticulously studying the afterglow of the universe's birth, what we call the cosmic microwave background. And in doing so, they stumbled upon a truly mind-blowing discovery. Our very own Milky Way galaxy and everything inside it, that includes you and me, is hurtling through space at an astonishing speed of 583 kilometers per second. To put that into perspective, at that velocity, you could travel from Earth to the Moon and back in a mere 11 minutes. Can you even imagine? The sheer speed of it all was enough to send shivers down the spines of even the most seasoned researchers. At the time, nobody really knew where our galaxy was rushing off to with such urgency. Now, a significant portion of that 583-kilometer recess can be attributed to the expansion of the universe itself. Think of the universe as a balloon, and the galaxies as little dots or drawings on its surface. As the balloon inflates, the drawings get pushed further apart from each other, even though they're not actively moving on their own. This is what we refer to as the Hubble flow. Another force that could be influencing the Milky Way's movement is the gravitational attraction, the literal pull, of our galactic neighbor, the Andromeda galaxy. We're currently zooming towards Andromeda, perhaps for a cosmic hangout, at a speed of about 110 kilometers s. However, even when scientists added these factors together, the results still fell short of the observed 583 kilometers s. Something was clearly missing from the equation. We were, it seemed, moving far faster than we should be, exceeding even the wildest predictions of our best scientific minds. As it turns out, our entire galaxy is being pulled away from the uniform expansion of the universe toward some kind of unseen, mysterious object lurking in the distance. And it's not just the Milky Way. Every single galaxy within a cosmic neighborhood spanning approximately 500 million light-years, encompassing around 100,000 galaxies, not residents, galaxies, is being inexorably drawn towards the same massive, unidentified entity. And honestly, it's a pretty terrifying thought if you really stop and think about it. With a touch of poetic flair, astronomers have dubbed this enigmatic object the Great Attractor. Sounds pretty cool, right? But the crucial question remains: what in the world is the Great Attractor? When you seriously ponder something capable of pulling entire galaxies off course across hundreds of millions of light-years, well, it has to be an astronomical object of significant size. It's like the universe's version of, I'm gonna make him an offer he can't refuse. Speaking of refuse, let's talk about gravity. It's essentially the universe's love language, with everything possessing mass experiencing its pull. The greater the mass, the stronger the gravitational attraction. That's the basic principle. But to attract 100,000 galaxies from hundreds of millions of light-years away, the required gravitational force would have to be truly colossal. And by colossal, I mean super mega ultra ultimate science level colossal. So, what could possibly generate such an immense gravitational pull? And perhaps even more importantly, what would happen if we were to be drawn into it? As the saying goes, when faced with two questions, answer the first one first. It's no accident that the nature of the Great Attractor has baffled scientists for quite some time. When astronomers aimed their telescopes in the direction they believed the Great Attractor to be, they were met with nothing but a murky void. If the universe were a simulation, one might suspect that the programmers deliberately concealed the Great Attractor. Alternatively, if the universe was created by a divine being, perhaps that being was a bit of a slob, leaving behind excessive amounts of cosmic clutter after creating the Milky Way. He crafted this magnificent spiral disk, spanning approximately 100,000 light-years in diameter and 1,000 light-years in thickness, adorning it with hundreds of billions of stars. However, he seemingly forgot to clean up the interstellar dust and gas clouds, obscuring our view when we attempt to peer through the galactic plane. The region of the night sky obscured by the Milky Way's plane is known as the zone of avoidance, effectively blocking roughly 20% of the extragalactic sky from observation using visible light, the light that our eyes can detect. And, coincidentally, the Great Attractor happens to be situated right smack in the middle of the zone of avoidance. Probably not on purpose, of course. That's why, for many decades after its initial discovery, the Great Attractor remained a cosmic blind spot, its true nature shrouded in mystery. It wasn't until the 1990s that scientists, by measuring its gravitational influence on surrounding galaxies, were able to sketch out the first glimpses of what might be lurking behind all that cosmic dust and gas. It turns out that the Great Attractor is located approximately 150 to 250 million light-years away, in the direction of the Norma constellation. And according to the best estimates, its mass is equivalent to a staggering 10 million billion suns. That's right, 10 quadrillion solar masses. At the time, the figure of 10 million billion solar masses wasn't just large, it was mind-bogglingly large, almost incomprehensible. One of the first things that sprung to mind for scientists, when confronted with a mysterious supermassive object with immense gravitational pull, was a black hole. But even the largest supermassive black hole known at the end of the 20th century, 21618, was far too lightweight to be a plausible candidate. TON 618 is one of the largest, most massive, and brightest single objects ever discovered. It has a diameter of up to 780 billion kilometers, which is about 2,600 times the distance between the Earth and the Sun. To put it another way, if you could travel at the speed of light, it would still take you almost a month to traverse from one end of it to the other. The supermassive black hole TON 618 powers a hyperluminous quasar, shining with the intensity of 140 trillion suns. These numbers seem so outlandish that someone hearing them for the first time might dismiss them as fake news. But even with these seemingly fabricated parameters, 21618 only has a mass of about 66 billion solar masses. Believe it or not, TON 618, while undeniably one of the most terrifying entities in the universe and a potential nightmare for any civilization, is still about 150,000 times smaller than the bizarre object that scientists were searching for. And even if you brought in the current heavyweight champion of black holes, Phoenix A, this cosmic monster with a mass of 100 billion suns still wouldn't even make a dent. But if the largest known single object is only a fraction of the Great Attractor, then what is it? A morbidly obese black hole? A multi-galactic superstructure built by a Type 4 civilization? Or maybe the hiding place of 673,000 lost Pokemon? Thankfully, new technological advancements in astronomy, including telescopes utilizing radio waves and infrared light, have enabled scientists to peer through the thick dust clouds, dimly illuminating the zone of avoidance and the mysterious entity lurking behind it. And what we have observed, believe me, I desperately wished I could fabricate something terrifying and haunting, is, unfortunately, just galaxies. Lots and lots of galaxies. While seemingly anticlimactic, uncovering the true nature of the Great Attractor helps clarify certain aspects of the universe. For a long time, we thought of the universe as a collection of 200 trillion galaxies, scattered completely at random. But that's not actually the case. In reality, if you could stand outside the universe and look at it, you would see a gigantic structure that scientists call the cosmic web. The theory suggests that the early universe was like a poorly mixed bowl of batter, with some areas being thicker than others. These denser regions possessed greater mass and, consequently, stronger gravitational pull, attracting more and more matter over time. Over billions of years, the richer regions of the universe became even richer, and the poorer regions, in terms of matter, became even poorer. Sounds a bit like capitalism, doesn't it? In this way, gravity, that weak but infinitely long-range force, has shaped the universe, drawing billions of galaxies together to build these megastructures. At the same time, it has also created vast, empty voids. Gravity is a remarkably quirky architect. No matter where we point our telescopes in the universe, there exists a clear hierarchy. Our Sun, for example, is one of hundreds of billions of stars within the Milky Way galaxy. The Milky Way is one of a neighborhood of approximately 80 galaxies and dwarf galaxies, collectively known as the Local Group. The Local Group is one of approximately 100 galaxy groups and clusters that make up the gigantic Virgo Supercluster. In the past, when the zone of avoidance was still a blind spot, we believed that the Virgo Supercluster was the most terrifying structure in our corner of the universe. But since its unveiling, the truth has been revealed. What we once considered enormous is beyond the imagination of the human brain. The Virgo Supercluster, containing approximately 45,000 individual galaxies, is merely a branch of an even larger structure, the Laniakea Supercluster. The Laniakea Supercluster is mind-bogglingly vast, and I honestly don't possess the writing skills to adequately describe just how immense it is. But statistically speaking, this supercluster spans approximately 520 million light-years, enough to line up 5,200 Milky Ways from end to end, and currently serves as the home address for at least 100,000 galaxies. And where does the Great Attractor fit into all of this? Well, the Great Attractor isn't located within the Laniakea Supercluster. It is the Laniakea Supercluster. Einstein taught us that space-time is essentially like a giant, stretchy fabric. When you place a heavy object on it, the fabric warps and curves. Lighter objects then follow the curves, moving towards the heavier object. The greater the mass, the deeper the warp and the stronger the gravitational pull. According to this understanding, the Great Attractor is simply the deepest point in that stretchy fabric in our corner of the universe. It's warped downwards due to the immense mass of the Laniakea Supercluster, pulling all the surrounding galaxies from hundreds of millions of light years away towards it. It all sounds terrifying, doesn't it? So, what will happen when we get there? Well, if you're in a hurry, don't worry, because we'll never actually get there. The Great Attractor is located approximately 200 million light years away. At our current speed, it would take us over 100 billion years to reach it. Aside from the fact that we'll all have long since shuffled off this mortal coil, we will never, and I emphasize never, reach it, even if we were immortal. The reason for this is the expansion of the universe. We may be hurtling towards the center of the Laniakea Supercluster at breakneck speed, but space-time, the stretchy fabric of the universe, is expanding at an even faster rate, even more ridiculously fast. It expands at an ever-increasing rate with distance, meaning the further away something is, the faster it's receding from us. Furthermore, the expansion rate of the cosmic fabric isn't limited by the speed of light, whereas our movement across that fabric is, at best, just shy of the speed of light. In other words, even if the Milky Way strapped rockets to its rear end and blasted towards the Great Attractor, ultimately, after billions of years, the destination would only recede further away from us. If you're finding this difficult to grasp, imagine two ants crawling on a balloon. If the balloon isn't being inflated, The ants will eventually meet. What they'll do when they meet, I have no idea. But if you start inflating the balloon, and if your lungs are strong enough, the ants will drift further and further apart, no matter how hard they try to crawl towards each other. I'm not sure if that's good news or bad news. What do you all think about this? Feel free to leave a comment below. As always, remember to like and share if you found this video mind-bending. Subscribe to BrainPop Universe and ring the bell for even more mind-bending content. And now, goodbye, and see you next time.